At the Newton's third law video that I did, something was missing. I guess I must have forgotten to push the record button at some point during the time I was making that video. And since I always like to present this as a reasonable argument for accepting Newton's third law, I'm just going to briefly tell you about another way you can look at the whole thing. So imagine that we have a chunk of stuff sitting in the middle of empty space. Okay, so this could be my coffee cup, or it could be, a piece of iron or a rock or anything, but it's in the middle of empty space where there are no external forces acting on it, and so we expect it to behave according to Newton's first law. However, let's think a little bit about what this coffee cup is. Okay, it's made up of atoms. You all learned that probably in 5th grade physical science or something like that. So it's made up with atoms, and I would guess, wouldn't you, that the atoms are all exerting forces on each other, because it's those forces which hold the whole thing together. If there weren't forces between the atoms, then if you set this coffee cup down on the table, it would just all spread out and run all over the table. So it's the forces between the atoms. And how many atoms are there? Well, there's something like on the order of 10 to the 23rd atoms in a macroscopic piece of stuff. And every one of those atoms, in principle, interacts with every other atom in the cup. So if you have 10 to the 23rd atoms, and you ask each atom how many pairs of atoms does it, how many times does it pair up with other atoms, you have a huge number of forces inside that cup. Now, of course, the most important forces are those which the atoms feel due to the presence of their nearest neighbors, but even that, they're something way more than 10 to the 23rd forces which are significant holding this coffee cup together. Now, in my picture here, I've just drawn 3 of the atoms, just to give you an idea what I'm thinking about. So here are the 3 atoms that I'm thinking about, and this guy experiences a force due to this guy. That's this force here. And it also experiences a force due to this guy. And I've drawn those as forces which point toward their neighbors. That doesn't necessarily have to be the case, but that's the way I've drawn them. That's the way we usually think of them. And similarly, each of these 3 guys experiences 2 forces due to the presence of the other 2 guys. So now let's think about it a minute. What if Newton's third law were not true? That would mean that these forces would not all add up to 0. Okay, because I've sort of drawn it the way it should look. That is to say, this force and this force look like they're equal and opposite, and this one and this one, and this one and this one. But what if they weren't? If Newton's third law were not exactly right, when you took all these pairs of forces that result from the interactions of the atoms with each other in my coffee cup, if you took my coffee cup and set it down in the middle of empty space and just watched it for a while, it would suddenly start moving because there would be an unbalanced force on it. We all know that's not going to happen, or at least let's say we accept Newton's first law. So in some sense, Newton's third law, once we understand what matter is made out of, Newton's third law is a consequence of Newton's first law. So that's all I have to say. I'll see if I can get this supplement inserted into the right place with the videos on the web.